Let's talk about tomorrow first before I answer any questions. It does count. It's not a practice exam. It does count. 15 multiple choice, 30 points total. It's either right or wrong. It doesn't matter what you show for work. I'm not looking at the work. I'm just looking at the answers. I did the answer key early this morning. Out of the 15 questions, 10 of them are topics from our 5-day review. 10 out of 15. Yes, that's 2/3 for our mathematical wizards in here. All right, are from here. The other 5, we could have mentioned it on a homework problem, or maybe I haven't mentioned it at all. Okay, so that's the way it's good. I think it really resembles the Regents. As I was doing, I was like, wow, this one's easy. This one's going to be easy. This one's, and then I got a couple, and I was like, oh, you're gonna have to think about those. All right. If the only preparation you've done is sitting in this class and watching me and nothing on your own so far, it's not going to be. You're just going to be guessing on most of them. Okay. So, but you guys have been putting in the work. I think it'll pay off tomorrow, and hopefully, it's a wake-up call for a few of you. Like, hey, it's the real deal. All right. I got to put in some work here before June 20th. All good, and then you'll take it as soon as you get in tomorrow. All right, I want to make sure you got the full class period because I don't know how long 15 is going to take you. All right, any questions? And I will give you the formula sheet you'll have on the actual test. You're not allowed to use the master one that you have been filling in. All right. Anything on the multiple choice, June 2023? Anything from the multiple choice? Because I'm doing parts 2 through 4 today for my exam. Anything we have from that exam we want to look over? Will, start us off, young buck. 20, everyone go to 20. Make sure it's filled in if I'm doing it in class. And it's blank right now. What's 20? All right, yes. Definitely, easily something you could see tomorrow, too. And tomorrow are not questions I made up. They are old Regents questions, so keep it fair. All right, an equation of the perpendicular bisector, JM. All right, there's 2 terms here. There's perpendicular and bisector. Let me talk about that word perpendicular. We know slopes already are negative reciprocals. So the first thing I need to find is what's the slope of JM, and that's using the slope formula, whether you know it and need it tomorrow and don't know it, sorry. All right, you may need one of those or a couple of those formulas on the sheet I gave you guys that's got the master, all the formulas on it that you need. So change in y over change in x, so -9 minus 1 over 7 minus -5, so 7 plus 5. So -10 over 12. I can look at my answers right now and say to myself, I'm probably going to have to reduce that because I don't see any 10s and 12s. So if I reduce that, that's going to be -5 over 6. All right, we just talked. It's got to be the negative reciprocal. So what's going to be the slope of my perpendicular bisector? Flip it and change the sign. It'll be 6 over 5. So just by without even finding the y-intercept yet, just by looking at those choices, I can tell it's not going to be 1 and 2 because they'll have slopes of 5, 6. All right, now I head to the y-intercept now. And the way I've been showing you in class since we've been reviewing is I use this equation, y equals mx plus b, and I get b by itself. There's a little snag here in this problem, though. The only thing really I'm confident is my slope is 6/5. Where do I get that x and y coordinate from? Because it's got to be on my perpendicular bisector. Okay, no problem. Here's JM. Here comes my perpendicular bisector. Bisector. Where's it go? Where is my dotted red line going through? Midpoint of JM. And that's where you get the XY point to plug in. You need to find the midpoint of JM. Again, do I know it or not? Midpoint of JM. Do I know the formula? So I'm going to add my x's, divide by 2, add my y's, divide by 2, and it comes out to be, what are we looking at here? 1 comma, that's 4. 1 and 4 for the midpoint. I do that correctly? 2 divided by 2, negative 8, negative 4. 1, negative 4. So now there's my xy point. So y, negative 4, x, 1, and then plus b. And now it's all your calculator. Move the 6/5 over to find what your b is. And then now you're going to have to go back to choices 3 and 4. Distribute, add 4. Distribute, subtract 4. Which one gives you the b value that you just found in the last part? All right. Look good, Will?
Yeah, thank you.
Yeah. Anybody else? That was a good question. That was a solid one. You need midpoint, slope. All right, here we go. Ready to head up the parts 2 through 4. Let's start. Here are the problems I'm suggesting for Friday. Friday, because you come in tomorrow, you're going right to the quiz. So if you want to jot those down, circle them if you plan on trying them out or not. There's just 5 problems from that section. And again, I don't have time to talk about them tomorrow because you'll be taking the quiz, so we'll talk about them first thing on Friday. Along with, I need January 2020 in class on Friday as well. Friday, I need those things in class. Because after today, I'm done with this exam. You guys aren't, but I'm done talking about it in class. Okay. Here we go. We're going to do a couple part 2 part 2s, a part 3, and the big dog. I'm going to do the big dog at the end here, part 4. Make sure you know, remember, all pen. All pen on parts 2 through 4, unless you're doing any graphing or any, it'll be on there. Construction, yes. All right, so all constructions can be done in pencil and any graphs can be done in pencil. This one here is neither, but it is a circle question, so 26, everyone. Let's start with 26. And the numbers, I got the number generator back out because I got to start hearing from some people. All right, first thing I'm telling you, the arcs are in a ratio of 2 to 3 to 5 to 5. At this point in the year, we know we got to put x's with them because we're going to end up solving the equation. Only time I don't put x's with the ratios if it's a partition question. Okay, anything else, got a diagram, let's put x's with them. So CD, we got 2x, DA, 3x, the other 2 arcs, 5x and 5x. All right, I know I'm going to have to solve for x. So I need somebody to come up with an equation based on this diagram. All right, it's a circle. Give me an equation that's going to solve for x. And let's start this off today with number 11.
15x equals 360.
Good. Brody added up all the arcs and got 15x, and he knows it's a circle, so there's 360 degrees. Go ahead, everyone, and find the arc measures now. Take that extra step and find the arc measures for me. $120, $120, $48, and $72. Going. Now let's get to the question. What is angle B? We first have to know what type of angle B is, right, from our circle unit. Angle B, remember what we called that one? That's called 27? Inscribed angle. Now I got to remember the rule. How did I find an inscribed angle? Half of its arc. Half of its arc. You are allowed to bring highlighters, colored pencils to the exam if you need them on a diagram. You know, I take a look, angle B. All right, what arc is it drawn to? It makes it a lot easier when I highlight it. Oh, It's actually drawn to 2 arcs, huh? So I actually have to take half of ADC, arc ADC. And what's the measure of arc ADC? How large is that arc? 27 again. 120. So I'm going to take half of 120. That's a 60-degree angle B. It's part 2. It's only worth 2 points. It's like a multiple choice without the multiple choice. You shouldn't be doing a ton of work. All right, you shouldn't be doing a ton of work. If not, it's probably because you don't know what the heck's going on. All right, these should not require a lot of work. All right, one more part 2 question, number 28. So it looks like I'm doing a reflection to get one parallelogram onto the other. Explain to me using rigid motions why they're congruent. Second time we've done this, I just want to make sure we have the proper wording down pat. What transformation just happened? 12, what transformation just happened?
Reflection.
Okay, so here we go, reflections. And you don't need to tell me it's over line L. They told me that already in the givens. Reflections are rigid motions, and I think you guys can, I'm pretty confident you guys can take it from here. Reflections are rigid motions, which preserve distance and angle measure. I will ask somebody one question now. 19, who's got 19? What do you want to use?
Thus.
Okay. Thus, parallelogram EFGH is congruent to parallelogram IJIJ. Well, before we move on, somebody asked a good question. I have so many things to tell you about the exam other than what's on, the material to remind you of. I'm going to forget something. So somebody reminded me in 7th period. Are we allowed? The question was, are you guys allowed to write all this shorthand that I've been doing up here? And the answer is yes. Anything I've done shorthand all year is fair game. If you start making up your own, remember, I'm not correcting it. So you're playing with fire there. Okay, if whoever's reading it is going to know what you're talking about. Like somebody asked, can I, instead of parallelogram, can I just do this? And I was just like, just do this or write the word parallelogram. Okay, because then we could get in the argument, well, what are you drawing there? Is it a parallelogram, a rectangle? Who knows? All good? All right, so there's 2 part 2s, 2 points apiece. Here's a part 3. Oh, love this one. It's been a while. Statements, reasons, get them out. Get it going. Yes. These fire me up. Been since Unit 10. And I'm not even going to walk around. I can already smell it, what you're doing. And I want to tell you a story that I don't know how many years ago, but on the geometry regents, they give us a rubric. Like, this is award this student this many points if they did this, take off this many points if they made this mistake. And on it the one year was take off a point if they did not write in the givens. They pulled this, or they pulled the old circle it and draw it down there. Okay, I don't care if you do that now, but game day you have to write it all out because technically it's an incomplete proof without the givens. Okay, so it is correct. I could see why they would take off a point for that. And you're there for how many? You have to be there for how many hours again? 2 hours, yeah. So I think we can manage writing it in. All right, here we go. It's going to be like riding a bike. Just get back on and it just comes natural again. Well, what if it never came natural? We're not going to prove PT congruent to RU unless... Thank you. Triangles are congruent. All right, let's do it. And this isn't that bad at all. Not going to be that bad. Last year's kids had it easy. All right, so I see the symbol perpendicular, so I know I got to throw these on there. All right, I have no sides or no angles written down that are congruent. That's on your job right now. You guys are going to help me write 3 pairs of congruent sides or angles that are all congruent to each other because I have none written down right now. Where would you like to start? 15, where would you like to start?
Angle R equals angle P.
All right, you went right for the jugular, right for the hardcore one. Nice. Angle R congruent to angle P. Yes, that is true. And it's your show, John, so go ahead. How'd you know that?
Parallel lines, or no, parallelogram implies opposite angle.
Bottom line, he knows his properties. That's how we know it. Parallelogram implies opposite angles congruent. And that gave me an angle. Bless you. Next up, any other sides or angles that you see up here for me? 5.
Angle PTQ and angle RSU are right angles.
Got to tell me the right angles before you tell me they're congruent. Good job, Claire. Angle PTQ and angle SUR are right angles. Perpendicular lines form right angles. Go ahead, now tell me they're congruent. Okay, I gave you 2 angles now. And let's, all right, if we know our stuff, we know the next one's not going to be the 3rd angle because that's not a way to prove triangles congruent. It's got to be a side. So now, even if you're stuck, you have to start searching for sides in those triangles that possibly might be congruent. All right, so keep searching. It's not that bad here. You know it's got to be a pair of sides. All right, where are those sides? 13. SU and QT. Why? You're going to say that? Well, what word did just come out of your mouth? Rectangle? Where did it say that, right, Chris? It doesn't say rectangle anywhere, right? It's a what? The whole thing. Okay, the whole thing, not the one inside. Everyone's making that mistake today. It's not the one inside that's a parallelogram. It's the whole thing. So go ahead. I still want to use sides, but not those. Got it. Good pickup. SR and PQ. Got it. Yeah, everyone is seeing this little rectangle parallelogram looking figure and thinking that's the one. That's it. What about RS and QP? Parallelogram implies opposite sides congruent. That gives me a side. You have one more hurdle to get over. What's the reason? Because remember, we have 2. We have angle, angle, side, and we have angle, side, angle. So look at your diagram. Where is that side? In between or no? And that'll give you the answer. Triangle QTP congruent to, what do I got on the other side if I go QTP? SUR. All right, what's the reason going to be? Finish this off strong. 19. Yep, that side's not in between. Good work. And now finish it with CPCTC. PTRU. And I say this isn't bad. You didn't even have to do any addition, subtraction, none of it. Just had to know your parallelogram properties. Whew. Questions, comments? Hi, Bridger.
If we do it like in a different way with more steps, do we get like points subtracted for like taking more steps to do it, or?
here's the rule. If you have extra steps that are not needed, they better be correct. Okay, so as long as everything's still correct, we're not going to take off because you did it differently. Absolutely not. But you may have added an extra step somewhere in here, which is fine, but it better be correct. Okay? Yeah. However you get it done, you get it done. Speaking of that, this next one can be done a ton of ways, and that is the big dog, part 4, number 35. Again, I don't know if I said this, I have 3 geometry classes, so who knows when I say what. Part 4 is traditionally a proof. I have no idea what type of proof it's going to be. If it's coordinate geometry, that's better for us. If it's not statements, reasons, because I think you got a lot more options instead of statements, reasons. All right, so let's graph this triangle ABC and talk. How am I going to show its isosceles? All right, let's prove it's isosceles. Again, I'm not going to see your exam. Not allowed to correct it. Organization, especially when it comes to these coordinate proofs. Number your steps so whoever's correcting it can follow along. Let me look at this first, this second, this third. Do we have a pretty good idea which 2 sides are probably going to be the 2 sides that are going to be equal? Just by looking at the graph? Yeah, probably AB and AC. All right, how are we going to get them equal? Distance, yep. Distance formula. Or if you're a Pythagorean theorem person, you can do that. I don't know. Did we write down distance on our master copy formula sheet? Or maybe you did already, but here it is if you don't have it. x2 minus x1 squared plus y2 minus y1 squared. All right, here we go. Let's find the distance of AB. So subtract your x's and subtract your y's and square them. Remember, after you square, you should always get a positive number. And just one more piece of advice before we move on here. Okay, you should be getting out square root of 50. Please do, unless the directions say so, please don't be a hero. What do I mean by be a hero? Don't simplify it if it doesn't need to be simplified. Because if you do and it's incorrect, you got to make up for it. And that's ridiculous, right? That you had the right answer and you just decided to go extra and it's wrong. All right, so just leave it, the number underneath the radical, which is square root of 50. And I also have to do the same thing for side AC. And also, you can't do this for side AC. Oh, it's going to be square root of 50 because I know it's isosceles. You better show it comes out to be the square root of 50. That's what we're testing you on. Okay, show me because, and also too, if you think you're clever on this one and you just go, oh, it's going to come out to be 5 squared and 5 squared, you're wrong. Okay, it's not going to be 5 squared and 5 squared. It's 2 totally different numbers that are still going to give you 50. So both distances come out to be the square root of 50. Everyone today has been asking me, do I need to show you BC is not equal to make it isosceles? And the answer is no, because even if it is, it would make it what type of triangle? Equilateral, which is still isosceles. All right, so you don't need to show me that. I do need a conclusion statement, though. Triangle ABC is isosceles because, and then, you know, whatever reason you think is best. Because two sides are congruent, because AB is congruent to BC. Okay, so that wasn't that bad. All right, let's move the figure now. Let's go right 5, down 5. Yes, Nick, sorry.
For the second step, could you put like two sides of a triangle congruent implies isosceles triangle?
Perfect. Yeah, that's perfect. There's no, like with these, there's no set template of how to organize it and say something. I'm only concerned that it's neat and organized. That's the only thing I'm asking from you guys. You guys write whatever words you think are best, put in whatever you think is best, as much information as you want. I'm just asking that it is neat and organized for whoever's going to grade it. Okay? Again, did I need it in step 2? I could have just did all this in step 1. It would have been fine too. All right. Other questions? Okay, let's move it now. Take triangle ABC and translate it 5 units right and 5 units down. Oh, hey, I don't know if anybody noticed, there's a key word in that problem, state. So you might have a graph, but we need to say A prime is this, B prime is this, and C prime. It just didn't say graph. I don't even need it graphed because it's optional. But we do need to state those coordinates when you have them graphed. So go ahead and move them. Make sure our coordinates match up and you're correct before we get to the last part. All right, last part. And if kids did get some points off last year, it was in this part right here, just because of the notation. Everyone try to form right now quadrilateral A prime, C prime, C. So I need to connect those vertices right now. A prime, C prime, C. Nope, wrong one. And prove it's a rhombus. My big worry is that you guys may or may not have enough information to show it's a rhombus. So can we talk about what would be your move right now to show it's a rhombus? What would you do to that figure? Say, because my fear is you'd say something and it would just make it a parallelogram and not a rhombus instead. Nick, what would be your go-to? All 4 sides congruent. That would be my go-to for you guys. Prove them all congruent. Was somebody last period said, prove the diagonals are perpendicular. Got to prove it's a parallelogram first then. Okay, a parallelogram with perpendicular diagonals makes it a rhombus. Okay, so but if you show all 4 sides congruent, automatically a rhombus. Okay, can't be a rectangle, automatically a rhombus. And how would I show all 4 sides equal? Distance, and I know, I hate distance formula. All right, then you better have a new way to do it then. And I know we're going to find 4 distances, but why do I only need to find 3? We already did AC, didn't we? So you don't have to do that over. You just transfer the answer right down. There's no reason why you guys have to show your work over again. So you can just say, hey, what's this, step 3? AC is radical 50. And then show your work now for A prime, C prime, C prime, and A prime. And just show your work that shows, hey, they do come out to be square root of 50. Again, you can't just write square root of 50. You got to show how you got it. And then at the end, make sure you write a concluding statement to say why it's a rhombus. Before I let you guys go on your own now, I would suggest before the exam, whenever, whether you're studying with a group or by yourself, you go through each quadrilateral and say, if I was asked to prove this on a coordinate geometry, how would I do it? Instead of making that decision as you're sitting in gym B facing the test. So if they asked me to do a parallelogram, how would I do it? What formulas do I need? If they asked me to do a rectangle, how would I prove that? If they asked me to do a square, how would I prove that? Have a plan going in how you would prove each figure instead of trying to think about it at the exam, which you may not have enough information for by then. Last thing, remember the whole pencil pen thing I talked about at the beginning in parts 2 through 4? This right here is what can be done in pencil. All the surrounding work has to be done in pen. All right, so the graph itself, pencil, all work around it, pen. You're on your own for the rest. Go ahead. What's up, Lacey?